Ladies and gentlemen, good afternoon. It is 3 p.m. In the beautiful country of the Netherlands, and together with me, I have the supply chain of LiDAR and 3D sensing for factory automation. Welcome back to another epic meeting. We kick off the month of December with an online technology meeting covering photonics and robotics. As products become even more complex, robots are essential not only to speed up production, but also to ensure customization and repeatability. And photonics in the form of 3D sensing is key for this. I remember visiting Global Foundries in Singapore. What an enlightening experience! A leading manufacturer of semiconductor chips, a huge plant, automated to the extreme. My first reaction, where is everyone? My second reaction, train tracks on the ceiling? Wafer cassettes were taken from a machine to a machine in different orders, looking almost random. When you have many processes operating in a single plant, making separate manufacturing lines makes no sense at all. The job of the humans is to troubleshoot problems and develop new highly adaptable autonomous processes. Current breakthroughs in 3D cameras will mean a game changer for industrial automation. We will involve brilliant companies like Civit, whose second-generation 3D systems let robots see with exceptional image quality. And this impacts all manufacturing industries. I hope to understand the role that photonics can play in medical robots, helping surgeons to perform delicate and critical operations time and time again, making the impossible possible. My VIP list in the Zoom room reads like the credits in the ultimate documentary on robotics. I'm calling out to the volume manufacturing companies on these planets, the robot manufacturers, and also the innovative camera and photonics companies. Those will tie the room together, and look out for those fascinating contributions around medical robotics. If you want to participate in our top-level discussion, the time to sign up for the Zoom room is right now. Space is limited, but the topic has no limits at all. No excuses, be there. And you are here, and all of you are here ready to do business. Thank you very much, all of you, for the constant support that you keep giving to the Epic Network. I just want to acknowledge a couple of things before we get the ball rolling. The first one is 649 friends that are supporting Epic, 649 members, making Epic the largest, but also most focused association in the world. We're making an extra push to define the topic as focus as possible to make sure that your technology have a potential supplier, customer, and partner in the room. We only have 3 more meetings until Christmas. So today, Wednesday, this week Wednesday, next week Monday, and next week Wednesday, and then we go on holidays. Have a look at the meeting that we have next week on Wednesday on photonics of food and beverage. Listen to that tip. It's shaping up to be excellent, shaping up to be fantastic. Also, this Wednesday on medical devices with Medtronic and with GE is also a great opportunity to do business. But we also already announced the topics for Q1, and I would like for you to pay special attention to the one that we have on the 15th of March, LiDAR 2.1 applications. In the last months, we collected many different LiDAR companies and principles, from Flash LiDAR to FNCW. We want to bring all of them together and address applications in the space, robotics, and automotive. It's going to be a spectacular meeting. Mark it in your calendar. And I'm here just speaking on behalf of a fantastic team of people who are specialized in technology. Half of them have PhDs, and they love organizing events, provide access to our network, help you raise capital if you're looking for investment. We have the biggest website to find a job in photonics, www.jobinphotonics.com, and we provide our members with market reports. We keep buying them from Strategies Unlimited, from Thematis, from Light Counting, and giving them for you for free as a membership benefit. And now, today we talk about LiDAR and robotics. First of all, I would like to acknowledge the cooperation of EMVA, the European Machine Vision Association, our partners in crime on this meeting. Thank you, EMVA, for supporting, and also all media partner, AZOnetwork. Thank you for making a lot of noise, a lot of attention, attracting attention for this meeting. And most important, this meeting wouldn't be possible without our sponsors today. So let's talk about them. First one, Finland. We go to Finland, we talk about Modulight, semiconductor lasers. They have MPE growth and they go all the way to offering full package solutions, all the way to offering solutions even to clinicians. Edmund Optics. You're looking for any optic or any filter, you have to go to Edmund Optics. Most of the production is self-made. It's a production manufacturing success story of the European and world ecosystem. Focuslight, after the acquisition of Limo, Focuslight has positioned themselves as a laser manufacturing with key applications and with key knowledge on micro optics, so a laser with the best potential focus beam. If you talk to Focuslight, you talk about laser beam shaping and laser production. And Asphericon, from the capital of optics in the world, from Jena, Asphericon offers a step up in metrology, in aspherical and freeform optics with a paradigm shift on the specifications for the accuracy of their shapes. And we go to Jabil Optics, one of the key companies we have in Epic. Jabil has been the manufacturing company that makes the GoPro camera and many other manufacturing solutions. And Tegema, all the way from Eindhoven, active alignment machines. If you're looking for a partner to do the assembly, packaging, and testing of your electronic device, Tegema makes fantastic machines based on active alignment. And we go to Jena again. We go to Jenoptik. Jenoptik is this company that makes the best optical instruments, including LiDAR sensors in automation and other industrial applications. Whenever you don't want to lose a photon, you have to talk to Jenoptik, the best integrator of optical systems in the market, and Excelitas, any optical photonic component, from a detector to a light source to a modulator. Excelitas is the key company that we want to always work with. And last, but certainly not least, a newcomer to the Epic family, Robooptic Systems. Welcome to Epic. Robooptic Systems is that assembly automation partner that you want to have whenever you are assembling optics into any vision systems, specialized in the industry automation, 3D vision systems. If you want to have the right partner for assembly, you contact Robooptic Systems. Thank you very much, all of you, for sponsoring this great event. And now today, since this event requires so many different knowledges from all the team, the person who's going to be co-hosting with me is Epic's innovation manager. Is the person who is leading the teams in lasers, the team in quantum, the team in optics, and the team in photonic integrated circuits. Antonio Raspa, it's an honor to have you with us. What's in the menu today?
Oh, the menu is very interesting, and today the supply chain is really showing how the photonics is a key-enabled technology, because it's really crossing all the industries. What is impressing me are the end users that we have. We are going from automotive to mobile phones to infrastructure company to steel pipes manufacturing. So here really we are having impact on all the industries, and this is very fine for me. And then we go around and we see so many differentiation in the photonics. We are speaking about semiconductor laser. We are speaking about materials, optics, instrumentation, manufacturing equipment. So really, this is really one of the most fantastic meeting that we are organizing, because it's showing how photonics has impact on our daily life.
And of course, you cannot highlight every company. This slide corresponds only to the companies who register for this meeting. But there are so many cool technologies today. You're going to see the LiDAR technologies from Luxi, from Scantinel. You're going to love what Bimaging or Ommatidia LiDAR can do. And not only you, because this meeting is broadcasted in YouTube. So hello, YouTubers in the world. If you have a question for any of the participants today, post in the chat. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-azok.com. And finally, for the people in the Zoom room, please use the internal chat constantly to talk to each other about what you can do for each other. This meeting is about business. And at 5 o'clock, we will finish on time. At 5 o'clock, you can stay in the room and we will set up one-on-one private meeting rooms for you to follow up on potential business opportunities. And this is all for me. Now the ball is in your court. Today is a meeting that was the idea of Jabil Optics. Simon contacted Epic and they said, we need to have this topic addressed by Epic. And that was a big challenge. And I wanted to start with a big name in the field. So today, Today we have Maarten Steinbuch kicking this meeting off. Maarten, goedemiddag. Thank you very much for being with us today. It is really an honor to have you starting this meeting. Tell us what you do in this field, and mostly what kind of opportunities for collaboration do you see with the rest of the EPIC members, all the way from beautiful Eindhoven. Maarten Steinbuch, the floor is yours.
Thank you, Jose, especially for your enthusiastic way of starting this meeting. It's a pleasure to be here. I will start sharing my screen, and then I can start with my presentation. I hope you can see my presentation. Is that
crystal
correct?
Clear.
Yes. So my name is Maarten Steinbuch, as said, and I'm a full professor here at Eindhoven University of Technology. I'm also scientific director of the Eindhoven Engine, which is basically an accelerator for innovation, where we, in co-location, have projects between companies and knowledge institutes, because I think it's really important to accelerate bringing new research results faster into practice. So I really like to work on this edge between knowledge and businesses. So in the starting video of this conference, you already saw some of the pictures of my group. At this moment, we are still world champion with our soccer playing robots. And I would like to start with that. I hope you can see the video sufficiently smooth. And it's in Dutch, but just watch it.
Zongier let helemaal niet op. Wat zeg ik? Robodinho aan de bal. En dan gaan ze proberen hier weer in de aanval. En dan is het, ja, heel goed. En nou draaien. Open doel. Robodinho. Oh, van het tandwiel. Van het tandwiel. Van het tandwiel probeert 3 man verdediging langs. 1 man, 2 man kwijt. Nu nog eentje. Van het tandwiel. Van het tandwiel. Ja! 2-2! Met nog maar 5 seconden op de klok. 2-2!
So this was 2013, the World Championships soccer playing with robots. These robots are completely autonomous. And this was just 5 seconds before the end of the second half. And in the Netherlands, we were behind China at that moment. And we scored this goal. And what I find really impressive is those 5,000 people. I was one of them, of course. And there were children, parents, grandparents, 5,000 people going out of their mind, so to speak, just by watching a set of robots. Not looking to humans, no, to robots. And it was if we are looking to humans, really impressive. Well, since then we have been many years already world champion in soccer. So we are still world champion in this mid-sized league. You see the camera system on top. It's a 360-degree camera with which we look. We don't use LiDAR yet. I can imagine that will give us a more accurate world modeling. We don't play this soccer game just for fun. One of the things we are working on are various applications for autonomous guided vehicles. And you see here one where we apply the knowledge of our soccer playing robots to manipulating a hospital bed. With the aim of applying this to hospitals, not only for changing beds maybe or relocating beds, but also to transport the clothing of the beds, etc. So also for the logistics in the hospital. This can only function well, especially if there are people around it, if the sensor technology, hence optics, is well developed enough to make no accidents and so on. So you also did see in the starting video of EPIC, you saw the medical robotics. So that's also from my group. For instance, this is the eye surgical robot. It's a master-slave operated, very high precision robot. So the accuracy at the tip is in the order of 5 microns, which is about 20 times better than the best eye surgeon in the world, and it's especially meant to do precise operations on the retina. And we are currently developing, together with the instrument you insert a fiber, an optical fiber, to measure really accurately the distance to the retina, to make a distance controlled or at least a safety system that you can never enter the retina in an uncontrolled way. Here you see the improvement if you compare the steady slave behavior compared to the hand of the human. And I'm driving a Tesla myself for many years, and in Europe we are not allowed to do many tests with autonomous driving, but this is just a plot from the internet, and in the States they are now rolling out the full self-driving experiments with normal people and normal cars, so to speak. And I see now the same pictures popping up on the internet as that we have in our research vehicles in our lab, where we do a lot with radar and LiDAR technology. Tesla states that they don't need LiDAR for autonomous driving. I think they will come back to that, because I think that LiDAR technology will be so cheap, it will be in every car in a few years from now. So I think there is a great future for LiDAR. Now, last but not least, I want to show you this picture, and it's very small. The key thing here is that I started 4 years ago with a PhD student, Matthijs van Gastel, and he will finish in March next year, finishing his PhD. And he developed an assembly machine for packaging to connect fiber arrays to photonic chips in a way which improves accuracy with about a factor 8. But especially makes it really fast. So his timing is that he connects 16 optical fibers to a photonic chip in only 4 minutes, with accuracies below 100 nanometer. And this type of machinery we need if photonics is needed to become a mass manufacturable industry. So with this, if you have any questions or suggestions, you can always contact me. You can see the contact details here. And I'll give back the floor. Thank you for your attention.
Thank you very much, Maarten, for being with us. It is really an honor to have you in the room today, and there are many different things that I want to ask you. But the first thing I want to do is to show you a picture, Maarten. I want to show you this picture. I want to show you this picture because this is one of the success stories of TU Eindhoven and the connection of the universities with the industry, with in this case Renault. Could you tell me about what's the success story between the Renault Twizy and
this Twizy is most people know the Renault Twizy. It's an electric car, but it's far from being an autonomous or semi-autonomous car. So we bought some Twizys, and together with Renault, we figured out how to rebuild this car into a completely autonomous car. And especially we are focusing our research on platooning, so that the cars can actually be a small train. And that's where we use the Twizy for. Yeah.
So with this picture in mind, I'm going to leave it here for inspiration. What kind of opportunities do you see for the photonics companies that are looking to enter this automation, this robotic, these autonomous machines market?
Yeah, I think photonics is providing an enormous development in chip and sensor technology, of course. And I think there are many applications where you need accurate measurements of your environment. And especially fibers can be so small, so measurement devices can be so small and lightweight that you can integrate them also in mechanical devices like airplanes, wings, but also in robotics in the end effector, so that you can actually really accurately look what you are doing. That's just for industrial automation. That's key. That the robots are no longer only dependent on external cameras, which have a low frequency range because of the low sampling, but that you have higher sampled systems so that you can really close the loop over the optics. I think that's for industrial automation. That's one of the key benefits of using smaller optical systems, I think.
Let's give the room for questions now. The first question comes from Sony. Faisal Kamran, a big friend of APEC. Faisal, thank you very much for being with us again today. Representing Sony today, congratulations. What's on your mind?
Thanks for the really good to see you in the same enthusiasm and the high spirits again. I just was curious about this claim that Maarten just made about he mentioned Tesla too, that Elon Musk has very openly talked against LiDAR on multiple platforms, even calling it a fool's errand. But Maarten has just actually said that it's very likely that the industry is going to get back to this LiDAR applications and not only the imaging-based system. So is it based purely on the cost estimates, or is it some other features he thinks is going to be genuinely important for the markets?
So to my knowledge, Elon Musk is just using say their radars and the 8 cameras, and he believes that that AI algorithms can utilize their data. But if I'm driving in the dark and there's a brick on the road, I think I'm happy that there are LiDARs in the future in my car. So I think the primary reason not to believe in LiDARs is that each system did cost 20,000 euros. But now you can buy for 250 euros, you can buy a good laser, and in the future it will be 20 euros. And then we will have 8 LiDARs also on our cars. And so I think with that forecast, the more sensors you have, the better it will be. Because radars and cameras alone, I think it will be good for 95% of the cases, but not for 100%. And for autonomous cars to succeed, for full autonomy, you need 100% coverage of all cases.
I think that's a fair point as well. And that's what I was trying to allude to as well, that one technology might not be ultimately the top solution, because there will always be certain gray areas or the dark spots or blind spots for that technology, which could be sort of filled with the alternative options then.
Yeah, exactly. And you know, if one autonomous car fails, so there was an Uber Volvo car which hit a female on her bicycle, as you remember 1 year ago. People don't like technology to fail. We accept that people fail, but we don't accept that technology fails.
Yep.
So if you can add sensors for a reasonable price, we will do that, I think.
Thank you very much, Faisal. Maarten, for many years you've been one figure connecting research to industry in the robotics. Today you highlighted the Precise project. What is the current status? How far did you go? What is your preferred future, and which companies would you like to interact with?
Yeah, so the Precise did ship their 3rd system now to the US, to New York. Even in the Corona times, they did not send a technician with it, but just a box and a manual. And the doctors in New York, they opened the box and they installed the system, and it simply worked. So that was great. Of course, not yet on humans. They applied this system to a human in Oxford, as was shown in the video you have shown. I also have a startup from the university in microsurgery, so to connect to suture veins, basically. And a third startup from my research is on a bone robotics application. And there we rely more on images of CT than on optical systems. But still, it's the 3rd spin out. Yeah.
I always love asking people for their preferred future and what companies would they like for them to be with them in this future. This is the supply chain today. It's a very good supply chain from end users all the way to system integrators. What kind of companies would you like to interact with to make the future of Precise and the other 2 startups the one that you have in mind?
Yeah, we already have a lot of companies. We have contacts with a well-suited supply chain. It would be interesting to have contacts with companies who are also interested to co-invest in startups, because you need a lot of money if you develop further into the medical field. You need a lot of money. So positive investors, that's important for us, I think.
We do have a network of 80 investors in EPIC, so we'll have a separate discussion about this. But I like the idea of having, as you said before, LiDAR is going to be part of the car, and we're going to be reducing the size, reducing the cost. There's a couple of companies, Scantinel and Ommatidia. I'm going to start with Ommatidia LiDAR. Eduardo Margallo from Madrid, from Spain. Eduardo, how are you doing today?
I'm doing great. Thanks a lot, Jose, for...
You saw the presentation from Steinbuch. They have this idea of making a platform which photonic technologies can help to go to further automation, and they are the world champions, as you could see, in the football tournament. So what can you do for them and with them?
Absolutely, yeah. So let me show you what we are doing at Ommatidia. We are a new venture in the field of LiDAR. As you were saying, let me see if I can share it. Okay.
Eduardo has been practicing this before, so I know he can do it. Yes.
Yeah. Is it good?
Yes.
Okay, yes. So we are developing a new technology for 3D imaging, which is actually inspired in the compound eye of insects. We make sensors with a lot of little channels, which are actually the Ommatidia of our sensors. And we build this, the scene from the information from all these sensors in parallel. And this allows us to combine the benefits of flood illumination, where you can distribute the power over the whole scene, with the sensitivity of continuous wave, frequency modulated continuous wave systems. And this sets us apart from all other architectures we know by increasing the amount of light we can use in really the imaging problem. So we have now a 2D system that's coming to the market around the summer for metrology applications, in particular with very high resolution, depth resolution down to 10 microns. And we are in the process of integrating and completing the development of the 3D system. We already have the sensors in. We received them just a month ago. We are really excited. There are 50,000 channels, 50,000 Ommatidia in there, which means that we have about 250,000 components, photonic components on the chip. I think we are getting to the limits of what's out there today. And the application for this will be more in robotics and autonomous vehicles, high fidelity AR, VR too. What we are looking for now is really short-term unmet needs in metrology and industrial fields, especially where large-scale, high resolution is needed. We have a project now on biodigester control under explosive atmospheres. We also have a project with ESA on high resolution metrology of large deployable reflectors. And we are also applying our solutions for characterizing large scale structures, infrastructure for trains and roads, where we can recover the 3D point clouds with high accuracy, but also can overlay an imaging vibrometry layer.
Eduardo, you have one of the ones to watch in your hands. I would like to congratulate you also because you assembled your supply chain a lot with a lot of EPIC members who have been helping and working with you. And also I live in Northvik, so I know about your location in the incubation center of the European Space Agency. Congratulations on what you are achieving. And I think there is already a couple of companies who are asking me to introduce them to you. So really, really good start of the meeting. In the last meeting that we did on 3D sensing, Maarten, a company called Sense Photonics made the mistake of saying, we are looking for partners in micro-optics. And I introduced them to 15 companies. Andrew Nelson is back asking for more challenges because we need to bring you back after what happened 2 weeks ago. Thank you for following up with each and every one of the connections that EPIC made for you. Sense Photonics is back, everyone. Andrew Nelson, tell us how the EPIC community can continue helping you. The floor and the attention of everyone goes back to Sense Photonics 2 weeks after.
Oh, thank you very much. Let me share here.
It is 3:28 in the Netherlands. What time is it over there?
About 6:28 a.m.
Let's have a nice early morning coffee.
All right. Can you see my screen okay?
I think you need to go to presentation mode. Yes, still. I think you went full screen, but did you go to the bottom left corner? Bottom right corner?
Share.
You will go full screen. Bottom right, the little projector button.
Oh,
presentation mode.
Let's see here. I think I might be sharing the wrong. I'm going to stop share here and then presentation mode on the
PowerPoint. Yeah, as I said before, Sense Photonics came with a Santa Claus Christmas list of components required 2 weeks ago, and many EPIC members asked to be put in touch with them, and I saw that there were follow-ups with all of the introductions. So on that was really what this meeting is about. So that's why we need to bring you back, because that was right. We got a lot of good positive energy from that. How are we doing IT-wise, Andrew?
Let's see here. I'm on now.
I think we are in business now. The floor is yours.
Okay, so I know that we have, I believe, 6 minutes here, a lot to kind of cover here, but I will touch base here, do a brief introduction. My name is Andrew Nelson, the VP of Sales and Business Development, background mechanical engineering and basically aeronautical engineering from Purdue, as well as business, and I've worked from the factory automation side with companies like Keyence and Cognex. I actually was a tier 1 contractor for Tesla for 3 years for 2D vision from 2013 to 2016 based out of San Francisco. And then I spent about 3 years at Velodyne LiDAR and now at Photonics for 3D LiDAR. So more than happy to speak of Tesla, know them very well here. I think that Tesla is foregone conclusion, they will go to 3D LiDAR. It's just that the aesthetic can't be fit into a vehicle and the cost. I think within 3 years, they will have LiDAR. Lastly, I would say on that is that it actually is very good for 3D LiDAR that Tesla does not, says it's a crutch, because 19 of the top 20 automotive OEMs in the world all say LiDAR is needed for your sensing suite. And to have one say it's not, it keeps 3D LiDAR in the news and everybody talks about it. And there's a lot of interest. And if everybody agrees, that's boring. So I think Elon knows all too well, and I know firsthand from Cognex, Velodyne, Sense as well. They are very interested and they have their thumb on where LiDAR is at and where it's going. All right, with that said here, what I'm gonna do is go over a couple use cases. The key with Sense Photonics here is that what we are doing is we're providing a 3D LiDAR, 3D vision system through flash LiDAR, and our ability to do it at cost. I could speak technically all day long. I have been at companies like Velodyne that's had 128 channels shooting 300 meters, and sooner or later you always get down to price performance. This is one factory automation application. What we have here is an image from the LiDAR using, these are ability to accurately reference distance points 5 meters away. The internal image is intensity, since we are flash LiDAR. And we basically, with VCSELs and as well as the SPAD on the receiving element, we have the ability to provide an intensity image. The actual image, RGB image, shows, there's something being thrown through the air here, this white package. The ability to pick up on white, black, all different incident angles with angles of reflection and a 3D LiDAR for literally today making a profit at $3,000–$4,000. Our costs could be driven down here over the next 3 years, but because there's no moving parts, there's no scanning, there's no sampling, there's nothing. It's 100% Continental. It's flash and OPA are the only technologies here that are not no moving, no friction, no scanning, nothing. So our MTBF is very strong, very high, but a large angle on this, as well as in the intensity image, you can see the black relative to the lighter objects, and this is about a 2 meter differential right here. We can still reference it very well. This right here is just another image of a company that either wants to go in and pick in place or see what packages they have or reference, what's in that bin. It could be picking out of this, it could be loading it into it. We're just colorizing the point cloud by distance. But again, these are going to be X, Y, Z. We also give calibrated reflectivity and the ability to do this. This is not, $20,000, $30,000, $40,000, etc. This right here is cobot locations. We have a couple, 6-axis, this Cartesian on the right, but a lot of times you have cobots where you have robots driving into the scene, delivering parts for some of these robots, and you have the ability to drive on both robots, but to localize themselves in 3 dimensions is very tough. And so what we can do is we can get up out of the way. Angle is not an issue. And we can do this here, 4, 5, 6 meters away, get out of a location and be able to actually do it more robustly than cameras. It's just that 3D LiDAR hasn't ever been the cost or been pulling the cost down of where it currently is at. As you guys referenced here, we are looking for a lot of different vendors from micro optics to anything on the software side in terms of creating object lists. There's a lot of companies. It could be Amazon Go stores. It could be other ones. They want to look and they want to be able to take a LiDAR and be able to go through a facility and be able to determine what's load bearing, what can we mount things to, what's glass, what's concrete, what's HVAC, all of these things. We can see that very easily, but we also need the algorithms on the side, both on board for edge compute as well as off board, to be able to process all this and be able to profile indoor environments. This right here is something where we have companies from 4 or 5 companies right now. Actually, they're using this in harvesting and driving up and down different harvest rows for crops because they're scanning apples every day and they can tell when the apples are rotten and they can get it out of the field right away. The calibrated reflectivity to be able to see things 5, 10, 15 meters away. It does not matter if it's night or day. It provides its own light. So with Flash, we provide our own light, and we are independent. It does not matter what time of day it is. On the left, it's just an image at midnight. On the right, it's just referencing, either reflectivity or distance. We could do either or. No, I'm moving very fast here, but what I'm playing here is a short video. What this is this is showing our LiDAR and what it sees. And again, I want to be clear, this is a LiDAR that is $3,000 or $4,000 today, and we're making a profit at that. These costs will pull down. We can't make them as fast as people want to buy them, and we are not a mechanical design firm, and so we will get much better at manufacturing. I dealt with challenges with lead times at Velodyne when we had a 9-month lead time for a VLP-16 puck back in 2016. Building LiDAR is hard, but we are looking for various partners, as well as developing technology to figure out what our strategy should be for EMEA, for APAC, et cetera, in terms of building long term. So, but the big thing here is that this is a sense one, we are selling product today, but also we are developing, as Hod spoke in his last time here talking with you guys. We have a pretty awesome technology here that what we'll be allowed to do is, with these breakthroughs in the SPAD as well as the flexible substrate, be able to go hundreds of meters. Right now, we have a product in the market that can go about 55 to 60 meters. We will be coming out with a product that can go 200 meters at 10% NIST targets in Q2 of this upcoming year, with betas to top automotive OEMs in like Q1. Now, it's a lot here, I had a lot of cover here, so I will stop there. Any questions?
Thanks very much for this presentation. And as usual, we have the epic question at hand. So what can we do for you, and what for the other, especially for the other people that are in this room? I'm thinking, for example, about automation as well, not only automotive, but so. And
I would say that there's a couple of things here that, I think with a lot of companies that are on this call here, it's not a matter of can a company do something, it's do they have the resources that are prioritization to do that. And so anything involving with drivers related to FANUC, Mitsubishi robots here, anything along the lines of being able to port in, various settings here where feedback of whether we should basically build up PCL libraries versus going the path of hiring an outside contractor to build up that ecosystem. Because right now the focus is building the best LiDAR, and it's all hardware. And what we're noticing is that from a software side, when you go outside the top 20 OEMs, auto OEMs in the world that have 5 to 20 perception engineers, you got to develop on the software stack. And so anybody that has either ties or could look at off-board compute or consulting here to look at software platforms, that would be of huge help, as well as anybody who has any experience or background in films in terms of optical transmission and films in terms of the actual lens, as well as heat dissipation. That would be another one. I think Hod last time talked about the micro optics. And then I would say that the last thing would be, we need to have, mechanical design folks when it comes to LiDAR, and the ability to reduce the size here as well as dissipate the thermals. Those are some of the, off the top of my head, come to mind that I could share on an open call that's not, tied to an NDA.
Hey, Andre, where are you located?
So Sense Photonics, we are located in North Carolina, where we actually manufacture outside of the Duke, North Carolina Research Triangle Park. We have an R&D lab and office in San Francisco, and then we also have a photonics team in Edinburgh, Scotland.
Okay. Yeah, thank you.
So I'm looking for partners for Sense Photonics because it worked really well in the previous two meetings. Simon from Jabil, when it comes to volume scaling, which is something that we need to help Sense Photonics with, is there anything that Jabil can do to help them?
Thank you, Jose, for making this contact. Hi, Andrew. A very interesting talk. Just as interesting as the 3D sensing talk you just held 2 weeks ago. Yeah, did I understand correctly that you are at the moment assembling systems yourselves, or you're looking for contract manufacturing partners if that's the case, it's certainly worth that mentioning that Jabil is one of the few companies that is able to assemble complex LiDAR systems on volume scale.
Yeah, I think that actually our upcoming technology here, we would probably need to come to that and be able to scale that quicker than what we right now we're in an MPI phase, but we'll be moving pretty quickly here to move past that here. And absolutely, I mean, I think that's something that's 1 or 2 quarters away from something where we need to have outside experience here to be able to run that supply chain, because it's we can provide the chip, provide the optics, and provide a couple other items here, and then basically develop the appropriate RASIC. And yeah, there's probably about 5 or 6 CMs we think that might be able to handle the volume within 1 or 2 years. And I think we've actually had some good progress in security for motion. I didn't get into motion analytics, pedestrian monitoring, asset tagging and tracking for people and all that, because it has a very high resolution LiDAR, 0.27 degrees angular resolution, which for a 3D LiDAR is unheard of at a low cost. But I say that because we, security has said, hey, look, it would be a benefit if you could manufacture this in the US due to some security traction we're getting with various government agencies. And so right away we're thinking, well, manufacturing in the US isn't always the best way to go, as you guys are well aware of here, but we may have to. And of course, a company like Jabil would be in San Jose.
It's a match made in heaven. It's a match made in epic. So I think you have to follow up. I'm going to introduce you, Andrew, to somebody from a company I just came across. They just joined Epic. The company is called Robooptic Systems. Johann, are you with us this beautiful afternoon?
Yes, hello, how are you?
I'm doing great. I'm happy to see you. Tell me how you can help Sense Photonics and all the other LiDAR companies in the room.
Yeah, may I share just a short picture where we are?
Of course, this is your meeting.
It's working?
It's not here yet. It's almost here. Yes, it's coming.
Now it's working, yeah?
Yes.
We are actually a machine manufacturer in this business since many years, more than 20 years. So our experience is to build, to manufacture projectors, to manufacture cameras, LiDARs, and so on. So the heart of our company is active alignment. So we have all these competences in our house, like machine vision, micro positioning, precision bonding. So everything, this is let's say, this is our DNA. And out of this, we are building machines. All the machines are looking completely differently because every customer has their own ideas, their own products. We try to do it on platform concept, but not all the time that's possible. So usually we design these machines together with the customer when the prototype is more or less ready. So we are going in a kind of process development to see what are the critical steps in that, and then we give a design in support back to the customer. And so together we build the machine, which can be produced as serial production. Yeah.
Thank you very much, Johann. So as you know, in Epic, we have a lot of the companies doing automation for manufacturing, companies like AZOnetwork, a lot of IAS, companies like Ficontech, like Tegema, all of them on the active alignment. But Robooptics, a company specialized on the camera assembly, especially for the 3D sensing and vision system. So it is great to have you here, and definitely Sense Photonics could perhaps help you, or at least there should be a collaboration. Andrew, what do you think? Is there anything that you can do together?
Yeah, I actually had a question here. Is that something that you guys have, like standardized platforms that you customize based off a LiDAR company's needs, or do you guys build from scratch here and kind of work with a prototype and then build with the design intent for a specific LiDAR company?
It's really depending what is the request and what are the needs. So there's a platform, and based on that we can where we have a toolbox, we can take this or that and put together. It's depending on the accuracy and so on, and what you actually would like to get out of the machine.
Yep.
Since Photonics is reinforcing the supply chain with companies in the optics, in the automation, in the volume production. Andrew, once again, thank you very much for being epic, and thank you all the members who are helping you.
No,
let's continue
thank
with
you.
the program. Let's move on, and let's now talking about the system integration. The system integrator by definition at Epic is DEMCON. Thank you very much, Edwin Gerritsen, for being with us this afternoon. Tell us about DEMCON and tell us how the other 648 members can make DEMCON even greater than already is. The floor and the attention of everyone is yours.
Hi, Jose. Thank you for the introduction. Can you guys all hear me?
Loud and clear.
Okay, let me start sharing my screen. Give me a second. Okay.
Beautiful Epic logo. The floor is yours.
Okay, so my name is Edwin Gerritsen. I work for DEMCON. I'm a mechanical engineer by background. So let me give you an overview of our company and specifically DEMCON Industrial Systems. So I'm part of the DEMCON group, a company founded in 1993 in Enschede in the Netherlands. We've grown over the years. And we now have something like 750 engineers, more than 100 million euro revenue. And we have different locations across the world. And we also export quite a lot these days. We are active in a variety of markets. So we started in high tech. So that's lots of semicon technology, but we also are involved on a project where we develop an alternative production method for medical isotopes. We've been in the news recently on many medical system applications, and we did respiratory systems. We also have a branch that is specialized in focal optomechatronic systems. So this is like optical metrology or laser communication systems. But I'm personally involved in our industrial system branch, and we are a high-end system integrator for the manufacturing industry. So we develop, create, and support client-specific production technology for companies that produce products. So we see these days that a lot of these producing companies are keen to get modular, scalable factory automation concepts that can scale with the business. So we work with small companies and big companies. We can do like production tooling. We do high precision pick and place assembly systems. So you see an example here of a high precision sub 10 micron vision assisted assembly station, which can pick up chips from a wafer and put them in a tray, for example, or you can use this system to pick up a chip from a tray and put it in a test card for a medical inspection application. We do micro machining stations. We do quality inspection systems for clients. We can do bespoke production machinery. We do pilot production lines. We basically are able to help clients to make the step from lab production or to manual production to full-scale production. We have, like I said, quite some engineers in many engineering fields. We have people, and we are able to help clients even when their vision on production is not totally clear, when the requirements are not there yet. Then it's still a good moment to talk with us, to explore what the next step for the client is to realize their production vision. We've also invested in our own building blocks. So we have system which we call our smart machine base. This is a standardized but still flexible machine concept that we can use as a starting point to make client-specific production technology. So here you see 3 modules that are connected to each other. We can do it with or without the top frame. We can use manual positions here, but we can also use automated feed-in technology. And this platform basically is pre-engineered, and it consists of all the support functions that are needed to make a client-specific solution. So we have the PLC in here, the human interface. We have all the safety functions already organized. We have electrical connections. We have the instrument air here. We have control cabinets. We have a pre-engineered modular software architecture. And by using this, we can very quickly work with clients and get their specific process implemented on this frame. So if you need to do any like precision assembly or inspection process, then I think this is a good platform to use. And then please contact us. Jose?
Thank you very much, Edwin, for your participation here. I was giving the floor to my colleague Antonio, but he said, okay, you take it. So I take it.
I'm thinking to make to change the epic question. So in this case, I don't want to ask what we can do for you and what you can do for us, but I ask maybe which is your shopping list. So you are in the Santa Claus supermarket. We are at Epic with 650 members. What you would like to buy?
Oh, I don't know. That's a trick question.
Technologies.
I'm not sure. Maybe the latest on optics or something that we can integrate in our system.
I would say just get good people, right?
Yeah.
So if anybody's looking for a job, contact Edwin, right? Or not?
That's true as well. Yeah.
DEMCON is one of the best places to work, actually. And I just opened an office in Singapore, and they are connecting with a lot of companies in that area. So it is great. I'm going to go back to the question by Antonio. This is the Epic meeting. So this is what people can do for you and what you can do with people. DEMCON is a system integrator. You say you put some of your example is building machines. What is the role that we see for active alignment that you see for the LiDAR industry, and what is the developments that DEMCON is doing towards building these assembly machines in production lines?
Yeah, like the example that I just showed. It would be nice to get into contact with people that really need high volume precision assembly systems. I think it would be great to work with companies that have that need. Then we can use our vision assisted setups to make that happen, to pick up small pieces and assemble that together, for example, or do certain inspections or finishing steps.
That's the perfect answer. Maarten, this is my trick. I asked a question because I know what people are going to answer. Do we have somebody from Scantinel in the room? Davide from Scantinel. They are actually setting FNCW LiDAR. FNCW LiDAR in Europe is possible with integrated photonics, and they are setting up the supply chain. Davide, are you with us?
Yes, here I am. Do you hear me?
Thank you very much for joining the meeting today. What is a Scantinel? What is FNCW LiDAR in one sentence, and how could you work with DEMCON?
Yeah, maybe just let me quickly share my screen.
Great.
So I can get it easier. Let me see.
It is coming. It's almost here. For many years, FNCW was only in California with the startups. We do have FNCW in Europe.
My screen now?
Yes.
Yep.
Good. So in a sentence, what is FMCW? Well, it's a different technology that is widely used in radar, and it's not based on pure time of flight, but instead of emitting a pulse and waiting and counting the time, it gets to hit the object you have in front of you and come back to the sensor. You basically send out a continuous wave, and then you mix it with a local wave that you have in your system, and from the frequency, then you can basically directly extract the distance of the object in front of you, but also from a Doppler effect, you can track also the velocity of the object. So the end goal is to have a picture where in every pixel you can measure not only the distance but also the velocity. And why is photonic integration a key enabler for us? Well, we are trying to get this solution in a compact size, and as always, in a very competitive price. And if you want to integrate it, you really need a photonic integration. And we are basing our scanning system on a combination of photonic integration and a standard optics. But also we are leveraging all the experience that IMEC, another very well-known EPIC member, is having on laser integration to have a very compact solution that will meet all the requirements that are there in the market.
Thank you very much, Davide. You are one of the companies that we really want to help in EPIC, because as I said before, FMCW is one of the winning technologies. What kind of cooperations beyond DEMCON, what kind of companies, Davide, you would like to work with in the coming months?
We are looking for any type of contact in terms of a possible proof of concept of our technology. We are now in a phase where we are setting up our supply chain. So every company that can be of help in the supply chain is very welcome. And we will have an evaluation kit from half of next year available to try our technology on the field, and this is what we really need now to make the next step in the development. And of course, we are also looking for investors. We have a clear technology path. We know what we want to do. We basically need some investors to do this together.
Okay, so this is great. We have all the supply chain here to help you. I think Yulia from Intel was with us earlier. Yulia from Intel, thank you very much for joining this afternoon. We just heard FMCW LiDAR for the first time, and they are looking for partners to test. Is there any room for cooperation that Intel could do with Scantinel, or perhaps you, Yulia, you could give some advice and some suggestions?
Okay, so let's see if I can give an advice. I have a couple slides to share. Is it a good moment to do that?
It's the perfect moment, Yulia. This is your meeting. This is you're the rock star. I'm just making you shine.
Great, thank you so much. Yeah, so thanks for the invitation. It's always great to be part of this meeting. Really amazing and very inspiring. So we represent a particular part of Intel. Intel is huge, and I'm sure they can offer computing devices and computing hardware for all kinds of workloads. And what we should have in mind here is after we have sensed all this information, like I've heard about 5D vectors here, so 3D information and reflectance and what was there else? And the motion information per pixel. And then we have X pixels where X is large. How can we process that all? So what our group is part of Intel Labs. So we're a research group who look into future of computing in a way. And in the future of computing, many people try to get inspiration from neuronal networks, from biological neuronal networks from the brains. And this is kind of the crazy revolutionary idea to look closer at how the brain computes. And this is where neuromorphic computing technology comes into play. And at Intel, we have one of the first kind of prototype devices that neuromorphic computing devices that can be used at least for research of what kind of computing could be applied for high volume, high density data to do some intelligent computing. So it's neuromorphic, it's neuronal network based. However, the neuronal network that is at the core of this hardware is of a particular type. It's called a spiking neuronal network or event-based neuronal network. Other people who have been at these meetings before, they've heard about event-based sensing, so event-based cameras, where each pixel detects change in luminance and reports this change asynchronously from all the other pixels. So instead of sampling your frames 30 times per second or 100 times per second, each pixel just asynchronously reports local luminance change. So now we take this principle further to the whole computing pipeline. So now the whole computing in the network is done asynchronously, where every neuron does not communicate real values to its fellow neurons in the network, but only communicates relevant significant events or spikes. So the neuromorphic hardware is basically a parallel mesh of such computing units like neurons that communicate with spikes asynchronously. And our research chip Loihi provides interfaces that can be interfaced to sensors. And what we are working on and our collaborators are working on is developing algorithms that would allow us to process that sensory input. I'll just show you a couple form factors of these devices. So they go from a little USB stick form factor to a large rack with up to 760 such devices that allows one to simulate 100 million spiking neurons. So you can have fairly large network working on this asynchronous principle. I'll just flash a couple examples of where we have some workloads that could be used in robotics. Now let's see if this movie will play at some point. So here we process events from such event-based camera to do gesture recognition. So you can see how this stream of events looks like, and the network on chip is capable to recognize in real time these spatial temporal gestures. So here it's a data set of maybe 10 gestures, and the network result can be seen in real time. Here we have another network. It's from a little demo that we developed for Intel Labs Day recently, where we have a fairly small network running on this chip, driven again by this event-based camera, and it learns on the fly objects and learns to recognize objects in the environment where the user can just put this object, it is learned, and then can be recognized in a slightly different position. If it cannot be recognized, then the user can provide a new feedback so the model can be updated. So it's really kind of updating the model on the fly. It's a small model, it's a small network, so it cannot learn hundreds of thousands of objects. It can maybe learn only 10 objects. But because we have this on-chip onboard computing, it can continue learning and improving models for this handful of objects. Another little example that I want to flash where we apply this technology is vision for control tasks. And the example we have here is ultra-fast control of this little drone that tracks the horizon at very high speed, so up to 1,600 degrees per second rotations. The visual feedback is not driven by a regular camera, right? Because with 30 frames per second, you wouldn't be able to track this disk by this event-based camera. And we have also implemented computing. So the visual computing, this line detection algorithm, we've implemented it with a couple of layers of a neuronal network. And also the controller itself is also running as the spiking neuronal network on chip. Yeah, so this little visualization just gives you a feeling of this compute with this asynchronous neuronal network on chip.
It is great to have you pitching so fast, and there are so many rooms for cooperation, Julia. Next time I'm going to give you like a full extended presentation. But if you could highlight... No, never, Julia, you're never done. Intel is a member of EPIC. If you have a potential room for cooperation, you could highlight this potential challenge that somebody could help you with. Could you give me that, please?
So we, in our hands, only have this computing device. I, of course, urgently need to connect it to some sensor. Like in the first step, maybe just get the data to work with, but we need to figure out what would be the best interface from sensing technology to a computing device like this. And then just figure out what kind of network would solve a particular task, and then benchmark it, test it, and try to go to new numbers in terms of power consumption, low latency, and performance numbers for our artificial intelligence applications.
Faisal from Sony has a question for you. Faisal, what's on your mind?
Oh, sorry, I forgot where the mic was, so I kept searching for it across the screen. So you showed your initial chip. Is it an electrical chip or is it an optoelectronic chip? And how many connections do you make in there?
So there's no optoelectronics involved in the chip so far. So that's they're using conventional electronics, digital chip. The connections that we have. So you know, we have this individual cores on the chip. We have 128 cores on one chip. Each core can have 4,000 connections to everyone else on the chip. The connection to the outside world, that's the big question that kind of still is yet to be explored. Currently, we use standard connections, right? Now, UART, USB, or this event address representation to get information onto the chip and to the neurons.
And this whole field of neuromorphic computing and application, I mean, it's a pretty vast application domain as well, and actually the potential for the use is really large too. But where do you envisage that, where the Intel is going to take the direction in terms of the application for this neuromorphic computing?
So at Intel, we currently explore broadly as well. So my last slide highlighted, right? So vision is a big topic, sensing more generally, so not only vision, but also auditory processing, tactile processing, odors processing, olfaction, so all kinds of sensors. I believe that also in control, in combination with vision, we also have a future. But at the moment, we're at this exploration phase where we look broadly. And then over time, we hope to focus on a couple applications.
Julia, Faisal, you know, it so far has been interesting. In 2 presentations we have outside, and you will be amazed. But before that, let's be serious now. Let's go to the automotive industry and talk to the key Tier 1 supplier. Valeo is here with us. Thank you very much, Marco, for taking up the challenge of understanding which EPIC members can help Valeo as the key Tier 1 supplier for the automotive industry. The floor is yours.
Thank you very much for this very kind introduction, and let me share my slides.
I love when people have the logo of their company in the white shirt. It goes very much with mine. It is almost here. Marco Heinen from Valeo and their mobility kits.
So, thanks again for all the organizers of this meeting for giving me this opportunity to present our mobility kits to this audience. My name is Marco. I have a background in physics, and I am now accountable at Valeo for, say, the technical development of some of the laser scanner kits that I will show you in more detail later. If you have any questions on the mobility kits and you would like to contact us directly, then please don't hesitate to write directly to the email address, which will be featured in the later slides. So, before we go to specific kits, allow me to please first introduce who we are. So, Valeo is a automotive supplier, Tier 1, with more than 100,000 employees worldwide. We feature products in visibility systems, thermal systems, electric powertrain solutions, and driving assistance systems, which is where I am working in. And this specific business group around comfort and driving assistance systems is targeting digital mobility, say the autonomous vehicles in general, including the detection and perception challenges, AI, human-machine interaction interfaces, and vehicle connectivity. So the autonomous driver assistance systems section of Valeo has now more than 30 years of expertise in providing systems to automotive industry. And in fact, today, every 4th car that is produced worldwide is equipped with some kind of our systems. In particular, and today I would like to point out that we are the first and only automotive-grade 3D laser scanner provider. We have by now equipped the first and second level 3 mass production passenger vehicles with LiDARs at the industrial scale. What you see here is a visual summary of our sensor and our perception portfolio, which is the largest one I would like to claim of any supplier in the market. This portfolio includes ultrasonics, various camera systems, radar and LiDAR, with the possibility, as you can see here, to achieve a full 360-degree coverage in the near range to the long range around the passenger vehicle. Our laser scanners of the first and the second generation are the first that have entered automotive mass production, and until today they remain to be the only one in automotive mass production. So what is this mobility kit business about? So in addition to the automotive series large-scale customers, we would like to open our portfolio and to make it accessible and available also for customers who are interested in smaller volumes, such as new mobility players or startups or research institutes. And this is the basis of our mobility kit initiative, which you see here. So each Valeo mobility kit includes one of our sensors, basically. And all of these kits are plug-and-play systems delivering Ethernet data streams with decoder software included. They are configurable to your needs with respect to integration and sensor fusion. Data is provided as low level as possible. So typically you get all point cloud or camera images and you can work with it. The interfaces are open as far as possible with simple software development kits or APIs, full documentation of the raw data stream and all the support that you can get from us. Here's an overview of which systems are available. Available right now are two different mid to long range scanning lasers. That's Valeo Scala Generation 1 and Generation 2. There's an ultrasonic system kit, and there's a surround view camera kit. Coming very soon is a dedicated near field flash LiDAR, and also second generations of both our ultrasonic kit and the surround view next generation. Along with these kits, we offer services and solutions regarding calibration of the kits, synchronization, temporal synchronization, and also functions such as LiDAR-based perception and localization, camera-based perception and localization, and also advanced visualization. Let me now get to three specific LiDAR kits. So the first one that you see here, this is Scala Generation 1. This is our 4-layer mid to long range scanning LiDAR. This has entered automotive series already in 2017, and it is now also routinely used by autonomous shuttle providers such as the one that you see here. It features a scan frequency of 25 complete point clouds per second. The angular resolution is horizontal 0.25 degree, and the distance resolution is 10 centimeters, or typically much better than 10 centimeters. It ranges up to and beyond 200 meters, as you can see here. Field of view is 145 degree horizontal, and you can easily combine several of these kits to achieve a full and cost-efficient 360 degree laser scanner coverage, as you can see in this picture that I've added, which is showing the surrounding of one of our testers. The sensor unit itself, it features a sleek and design form factor, and this facilitates integration into even production cars, as you can see actually in the snapshot. What is the content of the mobility kit? Well, as I said, this is the plug-and-play mobility kit. The kit includes the laser scanner itself, a mounting bracket for easy installation into your platform, a USB drive with documentation, CID files for integration, interfacing software, example traces, and so on, and also all the cables and converters that are required for operation. So the only thing that the end customer needs to provide to run this kit is a host decoder PC with an Ethernet interface. So this brings me to Scala next generation, which is Scala Generation 2. And it basically differs from Scala Generation 1 in the scan pattern and the field of view. Scala 2 is a 16-layer scanning LiDAR, as opposed to Scala 1, which has 4 layers, with otherwise similar specifications as regards the resolution and the range. In particular, this scanning LiDAR features the same high scanning frequency of 25 full point clouds per second, and also the very similar, almost identical design and form factor. And as you can see now on the example point clouds that I'm providing here, even a single Scala 1 mounted on one of our test cars produces a very high resolution wide coverage and three-dimensional representation of the environment. Of course, you can also combine several of these mobility kits to get a full 360 degree coverage, and still it's a cost-efficient solution. Next, I would like to introduce the dedicated near-field LiDAR kit, which is not yet, but very soon available. So this is a high resolution 0.3 degree angular resolution device with a typical less than 5% relative error in distance. And it features a scan rate of up to 80 Hertz, so 80 point clouds per second. Shows a wide field of view of 110 by 78 degrees, which has a 320 by 240 pixels. And it can measure down to the ultra near range, say 5 centimeters. At the same time, up to 30 meters for typical object reflectivities. The design here is entirely solid state, and the form factor is very minimal, which again allows for easy platform integration, just as the Scala 1 and Scala 2. In fact, this one is even smaller.
Marco, can you get a bit closer to the microphone? I'm losing you, and I really don't want to, because this is a room for opportunities that we have here.
So as you see on the snapshot, the typical output here consists in an intensity image and a point cloud, where the point cloud, as you have seen before, is intensity color coded. This concludes the mobility kits that I wanted to show you. And maybe let me finish with a more meaningful slide than this one. And let me once again thank the organizers and all of you for your kind attention. And in the remaining time, I will be happy to answer your questions.
Thank you very much, Marco, for your presentation. And as you understand that your presentation made already a lot of curiosity and already a question for you. So we start from Farzad, and then we have other questions in line. So very interesting presentation. Thank you very much. Faisal?
Okay, hello, Marco. Thank you for your nice presentation. I have one question. In how far have you invested in miniaturization of the electronics of your LiDAR? And did you develop any microchips or ASICs for that or not?
So I would like to point particularly here to the near field LiDAR. Do you see the slides too? Yeah. No. This has so the next generation of this one, once it becomes a generic mobility kit, will have all the electronic control units on board, and it features this in a form factor which is, say, less than 10 centimeters. I don't know if this answers your question. The other devices that I have shown, the Scala 1 and the Scala 2, derive from automotive series production, and they have the full PCB, including the ASIC and the logic, so the function logic behind.
Yeah, I think did that answer your question, Farzad? What kind of room for cooperation do you see between Sun Microsystems, Farzad, and Valeo?
I have a short presentation. May I show this?
Of course, but you know, this is your meeting. I work for you. Always show your slides. I love when you bring toys to the meeting. What can Sun Microsystems do for Valeo? When it comes to the ASIC packaging, Sun Microsystems is one of the key companies we have in EPIC.
Let me know when you see that.
It's almost here, but you can start talking. It will arrive eventually. Yes, it's here.
Is it there?
Yes. Yeah. Go on. It's okay. Farzad, are you with us? We had your slide, but we don't have you anymore.
Okay. You have that slide. Okay, that's very good. You hear me well? Okay.
Loud and clear.
Just a message that I wanted to give here today. Although it might be clear for many, but it is never enough to emphasize it. And this is, to be competitive in LiDARs, one need to miniaturize it. And this through co-packaging and in development of the receive channel, so the co-integration in one ASIC or package. That means the detector, the low noise front-end electronics, and the ADC all in one chip or in one package, depending on the package that they have. And we provide support to develop mini ASICs or MPWs, or also full custom ASICs with partners in EU projects. And also in the transmit channel, there are very high power and very small laser pulses, so very thin laser pulses necessary there. And we provide specific co-packaging solutions with our partners to minimize the parasitics in that. And last but not least, also in FMCW LiDAR, there is a challenge, and this is the non-linearity of the laser modulation over the laser wavelengths modulation over the time. And we provide support to minimize the non-linearity of the laser frequency. Yeah, this so far the points. And if you want to miniaturize something in your LiDAR, then let me know.
Thank you very much for that, and thank you for your helping already so many members in miniaturization and packaging of the ASIC with the Photonics, and it's great to have you with us. Marco, we have a question for you from IMEC, and we always mention IMEC a lot when it comes to LiDAR. I mean, what's on your mind?
Okay, thank you, Jose. So I think Valeo is one of the big player in this LiDAR automotive market, and I see that they are good. They are product that coming out. So, but what I see from the images, it looks like a mechanical or based on the array. Is there any plan to go for maybe next generation solid state LiDAR without mechanical moving part?
Like the million-dollar question coming from Amin. Can we integrate photonics with Valeo LiDAR, please?
So the flash LiDAR, which I have promoted, is already entirely solid state, of course. You are addressing the two scanning LiDARs, Scala 1 and Scala 2. So while there are investigations ongoing, I want to emphasize that the two are automotive grade, so they are resilient. So typically the criticism is that LiDARs with moving parts are not resilient to external shock or external influences, but we have a good counterexample here. We have two LiDARs with spinning mirrors, and they are very well automotive grade. So you can run these in customer cars for hundreds of thousands of kilometers, and they will not break down. So I'd like to make a point of spinning LiDARs not being out of the game. Yeah?
And what about the cost? I know that also maybe when you miniaturize it, you reduce the cost also. That is the whole point of electronic also miniaturizing. We are at IMEC promoting this photonic integrated circuit to reduce the cost because we can produce it in wafer scale.
Very valid point. And cost is precisely what we are targeting. As I mentioned, the solutions that I showed you are very cost efficient as they go back to automotive series production. So what we are selling here are mobility kits, which are parts, say, taken out of the series production line, so at very cost efficient mass production, and we are adapting them to the generic needs of small volume customers. So what you get in these kits is the quality of series production hardware, but the output is more generic, so you get access to the raw data.
The work on IMEC on the no moving parts beam steering on silicon photonics is outstanding. I mean, thank you so much for being with us. And I think, Marco, there is some room for cooperation here. Marco, many companies are texting me and they are actually telling me that they want to get in touch with you. So I hope you are ready to some one-on-one discussions afterwards. I'm going to move to the next presentation. I can't wait for this one. Outside. I love this company. Thank you very much. Thank you very much, Sebastián de la Bastille, for being with us today. Tell us how the EPIC members can make Outside even more known, even more hyped, and even more success story. And already is. The floor and the attention of everyone. I can't get enough of Outside. The floor is yours. Sebastián, we see Outside as a definition in the dictionary, but we cannot hear you. No, the video is great. It's the sound. We cannot hear Sebastián.
Yes, hello,
yes, here you are.
Thank you very much, Jose. So it's my pleasure to have the opportunity to present you what Outside is doing. Let me check. So outside, let me. So I guess you are seeing my screen?
Crystal clear. Crystal clear. And if you want to change slide, normally the space bar normally works.
Yeah, normally, and it doesn't in that case. That's
All
the
right,
point.
so let's try again. But as I was writing in the chat, outside has gotten a lot of attention recently over the last year from the community, and they have a good set of unmet needs that we want to solve in this meeting. Let's try to share the screen again.
Exactly.
And let's see how your Apple computer can make this presentation the way that you deserve. Let's go full screen.
And it works.
And we're in business. The floor is yours.
Exactly. So I am coming from the Google company. Before I joined Outside, where I was in charge of the AI business in EMEA within Google Cloud, working especially with the Edge TPU AI accelerator, as well as the entire AI software suite. And the company has been driven by Raoul Bravo, who was before the founder of Balio, a great innovator in the area of logistic and autonomous robots, as well as Cedric Hutchings, the founder of WeThings, who made millions of connected devices. So it's a great team, both to develop, scale technology, as well as manufacture it in a million of pieces, with a great team behind. And the company is solidly funded by a number of industrial players in different industries, as well as financial partners. Our main office is in Paris, but we also have offices in San Francisco and Helsinki. Basically, we start from the idea that 3D LiDAR will really unleash the spatial intelligence market with a lot of new applications. But there is a gap which today exists between the generation of the raw data generated by the sensors and the usable data which are required to see the surroundings and develop your application based on the perception. More and more sensors are coming, but they are generating more and more data which are extremely complex to process and to understand, especially when you are trying to see moving objects from a moving sensor with a lot of different objects. And the more information you have, the more resolution, the bigger the point clouds, the more difficult it is to process, especially if you don't have an unlimited processing power and you don't have an unlimited power available. So this is this gap which Outside is filling by proposing a perception solution in the shape of a preprocessor. So it's a box, it's a physical box, a hardware, which can be considered as a LiDAR pre-processing unit. Preprocessor from the point of view of the application developer. So the application developer will not talk directly to the LiDAR using the raw information, but will talk to the LiDAR through our box and will access information at a higher level. Higher level, it means that our augmented LiDAR box is bringing consistency to the raw point cloud. Time and space consistency, first thanks to the SLAM protocol, so simultaneous location and mapping protocol, which can work in 3 or 6 degrees of freedom. So it works both for terrestrial objects as well as flying objects. And so we reconstruct the map of the surroundings, the position of the sensor in this map, even if the sensor is moving, and the position of any single item in the surroundings. And this map can be a geo-reference with a GPS, IMU, or any other external positioning system. And then we can make a lot of different algorithms like point-wise perception. So we can classify each point in the cloud according to their category, whether it is the ground or a road or side of the road or movable objects. And then we can go even higher in the perception stack by giving an object ID list with their bounding box, speed, position, orientation, and classification. And we can do also a lot of other processing. And this works with a very wide range of LiDARs. And in the picture, you can see just a number, which are the most popular LiDARs. And basically, the same box with the same software can work with all those different LiDARs, and will provide a unique interface to the host, to the application developer. So we will significantly reduce the complexity of integrating a LiDAR into an application. Basically, we see the market as two main markets. On the left, smarter premise or environment. So basically, it's when the LiDAR is used for infrastructure. So the LiDAR is fixed. And when usually you need to fuse the information from a large number of sensors to give a consistent perception from a large environment. And on the right, you have the use of LiDAR on vehicles, so what we call the smarter machines, because it's much more than vehicles. It could be robots and other moving objects. And this is an example where on the left, you have the raw data generated by the LiDAR with a fairly poor resolution. On the top right, you have the point-wise classification, where we have increased significantly the density of the points, as well as the classification. So you can see that we bring semantics to each point. And on the bottom right, you can see the clustering, the bounding box, and we can generate as a flow of data the position and the speed of any single object, including when the object is moving at more than 200 kilometers per hour. Because here you can see that the sensor is moving on one lane, and so the vehicles on the other lane have a speed which can significantly exceed 200 kilometers per hour compared to the sensor position in the using the sensor as a reference. So that's an example for moving objects, and this is an example for the infrastructure. On the left, you have a flow of people in passport control area, as it is seen by 3 LiDARs sailing mounted. And so you can see the lines of the LiDAR. On the top right, you can see how people have been clustered. So your eyes can recognize the people because we are used to that. But here we show that the machine has also identified the different people, and that's why they have different colors. And on the bottom right, you really have a representation of the position of each single person in a UX, which obviously helps to manage people at a very fine level. And that's live in action. So the technology is really mature, right? It's deployed, and we are watching hundreds of people and vehicles every day in our deployed infrastructure. So that's the top view. But I think I will save you this one. That's just the view, for a final user. He really has a very fine level of control of the position of individual in a very large location, which is especially popular these days around people monitoring in every places which host a large number of people. And that's live, obviously. Generally speaking, our technology can unleash application in a lot of different industries, either machines to make smarter and safer machines, or robotics and drones, also for live 3D mapping. And I insist on the live because all our processing is real time. So we generate our information between 2 LiDAR frames. So at 20 Hertz, all the processing is done at 20 Hertz for infrastructure, logistic order, and transportation. I know also you will ask me the question.
Of course.
What are we looking for? We are looking for integration partners. So people who have as a business the integration of a perception solution into an end-to-end solution. We really deliver the technology. I show as an example what we are doing in an airport, but our business is to provide technology bricks. So really the pre-processing units for third party to take our technology and to integrate it together with a LiDAR into an end-to-end solution for their particular business. We are not an expert in any specific business. We are really agnostic and we provide our technology for a wide range of applications.
Thank you very much, Sebastian. I always put the expectations very high when outside speak at any event, and I think you surpassed them. It's very clear that what you are bringing to the community. The big question. So on one hand, of course, we want the integrators that want to integrate your preprocessor into any LiDAR and 3D imaging system. When it comes to the rest of the supply chain, we are only 20 days away from Santa Claus. What is your Christmas list?
In terms of integration?
Yes.
Yes. So it's really people who use old technology, which could be 2D LiDARs or any kind of, I would say, old sensor, and who really want to optimize either the performance of the cost of their solution. So that's the typical partner, whether for vehicle control, or for industrial application, or for people through management.
Marco from Valeo, do you see some room for cooperation here? I'm obviously looking at you. Velodyne is also somewhere in the room, but they are remaining anonymous. Marco, what do you think? Is there some room for cooperation here?
Most definitely I do. So we are already offering AI solutions along the classification of pedestrians and various vehicle classes, but I think this could profit from the various short to long range kits that we are offering. They fit very well into the lineup that I see here.
Fantastic. I think you're going to discuss this offline. And of course, I want to have the entire supply chain here. So we have somebody from Hamamatsu in the room. I think Laurent Demeset is here with us. Laurent, we heard a lot of LiDAR manufacturers. We even heard preprocessors. We put them in different systems. We heard from Intel. What could Hamamatsu bring to companies like Outside, to companies like Ommatidia LiDAR? Laurent, I know you are there, but you're muted, so I cannot hear you.
Mute?
Yes.
Yeah, unmute. So please send first my salutation to Carlos. We have a great party golf last summer.
He's my boss, so congratulations to Carlos means congratulations to the whole Epic. Hi, Carlos, if you're watching.
Yeah, but I am a good Japanese student, so I focus my presentation over industrial LiDAR and factory automation. So I really skipped automotive LiDAR. I really skipped it. Anyway, it will be a great opportunity for your next LiDAR Epic event to present you any ACQ102 automotive application, ACQ, which is really, really important in point of view regarding the reliability. But I can show you my industrial presentation regarding LiDAR and factory automation, but maybe as of today, maybe it's out of the scope, maybe.
Laurent, the most important thing here is what can you do for the others and what can the others do for you? The epic question.
Yeah, of course. Frankly speaking, to be honest, we are speaking to almost 60 to 70 companies worldwide, and I know all of them.
Very good. So what can Hamamatsu do at the end of the day? You can provide anything from SPADs to light sources from the LiDAR segment. And when it comes to miniaturization LiDAR, you have been the key company.
Yeah, of course. Something will be introduced within Q1 regarding especially laser at 905 and especially regarding also some emerging technology regarding SPAD. Not SPAD. SPAD for us is not so good. We call it MPPC because MPPC has a wider dynamic range, with a clever ASIC and so on. We'll show you something, but I was about to introduce you about industrial LiDAR, which doesn't need ACQ. I mean, for people about automotive, they know ACQ for sure. And for industrial LiDAR, you don't need ACQ, and it's easier. To be frank, it's easier business, easier and faster. If you are looking at automotive only, when you have two things to be care of: ACQ and price.
Yeah, indeed.
and
on that,
volumes.
Thank you so much, Laurent, for this. We have companies like Broadcom, like Sumitomo, like ST Microelectronics in the room. Lots of things to discuss.
They know perfectly. They know perfectly.
Of course, yes. You are Hamamatsu. We want to go to the next speaker today. We want to go to Elmos. And the reason for that is, in my opinion, Elmos ties the whole room together with potential cooperations. Thank you very much, Mirta Valenzuela, for being with us today. The floor and the attention of everyone goes to Elmos. Let's do some business.
Okay, hello. Hello, José. Hola, José.
Hola, Mirta.
¿Qué tal?
Hacer negocio, to do business.
Así es, yeah. Okay, one moment. I will share my display here.
It's almost here.
Could you see my...
You have to go to presentation mode, which is just click over there. And the floor is yours.
Yeah, thank you. Okay, my name is Mirta Valenzuela. I'm a global sales manager and business developer for Elmos Semiconductor. Elmos Semiconductor is, as the name says, we produce semiconductors and sensors for the automotive industry. In principle, for the automotive industry, more than 90% of our business is coming from these applications that you can see on my slide right now. For instance, we have ICs, integrated circuits for ranging, for ADAS application, for interaction with different sensors, also for the optical sensor, optical applications. We have the gesture recognition technology, but also we are working on LiDAR now, you will see in the next slides. And motor control, lighting, safety, and customized ASICs. No? We develop also this kind of technologies. With our 1,300 employees worldwide, we reached last year 295 million euros as revenues. We are still a small company. That's why we are also here. I will move now. My focus today is the ranging and the optical segment because we have here more interaction also with industrial customers. One moment, the next slide. Sorry, this is first. In ranging, we have the ultrasonic sensor solutions for the assistance parking. As you can see, there are different architectures using already the Elmos IC. And what we see now is that the companies in the robotic industry also are interested for this kind of technologies. No? We are now working with some companies in the USA, in Europe, in Asia, companies that are implemented already the ultrasound or ultrasonic technology into this kind of robots that you can see, the delivery robots, for instance. You will not see delivery robot with laser scanners, which now cost 5,000 euros to 20,000 euros. Now, for this kind of robots, you will need a low-cost solution. And this is one of the advantages that we have in automotive. We have low cost. We are automotive qualified. You don't need to do any tests if you want to implement the technology for this kind of applications. Also, in drones, you can see for the soft landing, you can use also this kind of technologies. We have a lot of samples and evaluation kits, just in case you want to test this, just let me know. And the next slide that I have, this is all the technologies that we have in the optical segment. We have for the display, for instance, for the display application, we have some technology for proximity and gesture recognition. If you have a Volkswagen, for instance, a Golf, you will see this kind of technologies already in this car. But we see also an increasing demand from the industrial, for industrial applications for this interaction with the displays. Now because of Corona, of course, you don't need to touch any displays if you have the possibility of use your control on the air. This is one of the technologies that are in which we have more than 10 years of experiences, but if you are looking for more resolution, for instance, if you want to detect a finger, or detect objects, then you can also use the TOF imager. We developed this technology also for an automotive application, for gesture recognition in exterior of the car. But we see also here demand from the industry. We have some cooperations with startups and with industrial companies in order to put this kind of technology also in the collaborative robotics, in which you will command or control also this kind of robots, yes, with gestures. Which is interesting from this TOF imager is that because this is automotive qualified, the low power consumption, which is a very interesting requirement for automotive, but also for the robots or for the mobile machines. This is one of the parameters that we deliver with this. You can see on the left side, for instance, the evaluation board for the TOF imager, yes, with 32 by 32 pixels. Maybe you will say 32 by 32 is it's not enough. It is enough for finger recognition and for object recognition until for a range up to 1 meter. Low cost is also very interesting, as a colleague from the partner from Hamamatsu also mentioned. Cost is a question. Also, we have the technology and we can transfer this kind of technologies also to the industry. And what we are doing right now is we are working on different technologies. We have new concepts for LiDAR, and one of these is the CMOS SPAD array. Right now, we developed some test chips, and as you can see also on the left side here, we developed already a chip with a 256 pixel by 16 pixel. This is a SPAD array, and also a laser driver, an integrated laser driver. As you can see, we will use more lasers in the future, also in automotive, but also for the robotics industry. And you need to miniaturize the system. And in this case, we could integrate 16 laser diodes only in 10 by 4 millimeters. This is a laser driver that you also can see here, the picture. But we don't only integrated the components, we also improved some parameters. As you can see here, we reach an ultra short laser pulse width from 1 nanosecond at 50 amperes current. And you can see the demonstrator, what we showed at the CES is around 5 centimeters by 5 centimeters, I think. It's very, very small. And again, we started to develop this kind of technologies for the automotive industry, but now we have a few talks also with the industry, because now there are a lot of laser scanners on the market and so on, but they are moving from the current, for the traditional technology that they have, to CMOS technologies. No? And that's why there are a lot of opportunities, I think, here, if you have interest to talk with us and exchange information about this. Okay. Thank you.
Muchas gracias, Mirta. Thank you very much for a great presentation. I love this slide. Don't remove it because I love it.
Yeah.
What kind of cooperations would you be looking at this meeting?
I worked all the weekend, my weekend with this slide, because it's
time very well spent, Mirta.
Yes,
what kind of room for cooperation? What companies can help you from EPIC, and how could you help them?
Okay, we are working with a lot of the companies from EPIC. I cannot mention the names maybe because we have some NDAs. But I got just some greetings also here. But also 2 weeks ago, or a few weeks ago, you showed or you had a discussion with Augmented. We are also in discussions with Augmented, yeah, because we need to develop the ecosystem here in Europe. Is very important, and we are open for this. We can give, again, all the technologies or test chips that we have are available. No, we can exchange this. And what is interesting for us is to learn more from the market. What are the requirements? What do you need? Because at the end, we are a technology company, but we need to develop the right products. And that's why it's very important to have the feedback from the customers, from the
Give us a couple of challenges. The first one, we are looking for VCSELs, right? VCSELs you're one of these companies who's bringing VCSELs to the LiDAR industry, like Iveo. Hi, Iveo. Elmos, describe me a little bit what would be your Santa Claus Christmas wish for a VCSEL.
For VCSEL, of course. At the moment, we are developing a new evaluation board for the TOF imager with VCSEL, but actually it's very difficult to get samples from VCSEL because I don't know, there are some cooperations already. You have to wait for the samples, and we are.
I'll get you the sample. Just tell me what you need. I'll get it and I'll pay for the shipping expenses.
Oh, thank you. Yeah, okay. The 940 nanometers, for instance, very interesting for us, and we prepare already our TOF imager. We made a lot of adjustment in order to work also at 940 nanometers. And what we need is to test different VCSELs in this area. No? And the other discussion what we have, of course, for the SPED arrays, we started to work with the high power lasers, no? Because this is what you need for the automotive industry, but there are already some solutions with VCSEL, and we need to talk to this kind of companies in order to go into detail, because, you know, Iveo, I think they have an ASIC, but this is a customized, but we need to learn more about the market and what kind of pixel array are they planning, for instance, for the future in this kind of application, and also in the industry, not only in the automotive industry. No?
Thank you very much, Mirta. We're going to have a lot of discussions about this. Many people are already telling me that they want to get in touch with you to talk about the different optics that you need. Muchísimas gracias, Mirta.
Muchas
Thank
gracias,
you very much
also. Thank you very much. And we are learning Spanish to hear.
You are fantastic. You really are. This slide is magic. You are really fantastic. You know, Mirta, this meeting, which has been great so far, this meeting was the idea of Simon Schwinger from Jabil Optics. He told me, this is a very important market for us. Let's try to build a supply chain of companies who could help Jabil. Simon, that's why I wanted you to be the last speaker today, to send us off the right way. What did you think happened? I know you already told me that there are many rules for cooperation with many of the participants so far. The floor and the attention of everyone goes to Simon Schwinger, goes to Jabil Optics.
Thank you, Jose. Let me share a few slides at the end of this meeting.
We saved the best for the last, of course.
I hope so. Can you see the slides?
Yeah, crystal clear. Quality of Jabil Optics.
Thank you very much. So at Jabil Optics, we believe that robots will become major enablers of automation, with large impact on economic impact. And if you look at the industrial robotics market, it's fragmented already, even though it's a young market. We see standalones in different versions. We see the automated guided vehicles, autonomous mobile robots, exoskeletons. So there are quite a few segmentations already coming up. If you look at the market size, and here we are using data from McKinsey, it's supposed to be in the range of 50 billion in total, and a good CAGR, so it's growing. Of course, even though it's a young market, there are a few challenges that need to be addressed, just from the perspective of robotics. So software standards, we figure there's something that needs to be addressed with regards to interoperability between the providers. At the moment, it's a burden on the buyer. We see virtually 100 AMR companies out there building identical or nearly identical hardware, and software needs to be kind of standardized, we believe. At the moment, AMRs are still somewhat expensive. So we are having a close look at the robot as a service concept. That might be a suitable response to that. We see or we saw limitations in 3D sensing. That's why we came up with a Jabil orbital sensor, which I'll explain on the next slide. There certainly is challenges in indoor and outdoor operation with regards to sensing and an IP rating. And then, of course, collaboration between robots, so accelerating human-robot interaction. That's something that is at the very beginning. And of course, the perception of AMRs replacing humans versus supporting humans. This tends to be looked at in a different way now after having experienced COVID, impacting worker safety, etc. But these are, let's say, the high-level challenges we see in this market. If you look at Jabil and what we provide, there's quite a few capabilities. Not all of it we have in-house, so we are also partnering since we are a contract manufacturer. But cameras, time-of-flight solutions, LiDAR, projection units are within the capabilities. We have additive manufacturing, automation, cloud and 5Gs, highly connected to robots. Active alignment has mentioned several times today. We also have this capability in-house. Printed electronics, sensors, the entire Internet of Things is playing a major role in utilization of these kind of robots. And Jabil is, as a contract manufacturer, able to provide FATPs of full final acceptance test and packaging as well. You see down here one of the robots we have already in the market from our company Badger Technologies, which belongs to Jabil. So we are quite active in this field already. In the middle here, you see the Jabil orbital sensor, and orbital sensing itself, to our understanding, is based on time-of-flight technology. We capture depth information in this context in a radial format. It's a large field of view, which is really decisive in this matter, and it's all about object detection and collision avoidance. So the device, the tool we have here is in the middle of the slide, provides a horizontal field of view of 270 degrees and a vertical field of view of 60 degrees. In the use case, can be attached in the, let's say, corner-wise on an autonomous mobile robot, like you can see here. And in this context, you can cover the entire area around the AMR. Not going through all the technical specification, but the wavelength range, 850 nanometers or 940 nanometers. We are going up to 5 meters right now. And there's already an independent patent portfolio being developed that is tailored around system, the optics, and the control. Some of the images that are being generated by the device are shown here. Yes, that's about it on that slide. A few words, since we are approaching 5 p.m. On Jabil. We are active in quite a few markets. We are about 240,000 employees worldwide, with more than 100 manufacturing locations worldwide, and achieving $27 billion in revenue. And when preparing this talk, I was asked specifically for the challenges and what EPIC members can do for us. So I prepared and saved some time for that. I cannot cover all of it in one talk, so I focused on optical design challenges. I don't know how many people we have here, but Jose, you can certainly take this into the community. When we talk about optical design, we see challenges in rapid prototyping. So printing lenses, especially for projection optics, it's all about speed. We need to get these fast. Raspa accuracy is a limiting factor at the moment. We are aiming at 10 nanometers irregularity in deviation of 1 to 2 micrometers. Second point here is measurement tools. There's a wide range of measurement tools available, but especially for freeform optics and especially the ones with strong surface slopes, we see that there's a limitation in the measurement tools available to date. We believe that there's a some promise in metamaterials, so nanostructured surfaces, supporting the way to the ideal lens, how we call it. Electron beam processing as a keyword, the buzzword here. The question, what functionality can be expected over time, especially in different wavelengths. So the IR range is at better phase at the visible range. And of course, since we are a volume manufacturer, what is volume manufacturability, writing speed, what can be accomplished. So basically, we are looking for companies that are working on pushing the technological boundaries with respect to optical designs, smaller lens stacks, lens thickness, edge thickness, and overall tolerancing of optical systems. That would be something of interest for us.
Thank you very much, Simon. Thank you for coming with this fantastic list of unmet needs, which of course I'm going to share with the whole community. I'm going to actually put most of it in LinkedIn after this meeting because I do believe that this is the room for cooperation. Let's go for one of the potential companies that I think you can cooperate. Let's go to Leon Lee from Focuslight. Leon, how are you doing?
Hi, hello. Hi, good. Yeah, I think I'm the last one, right? You saved the best for the last.
Of course, always the best for the last. Focuslight, after acquisition of Limo, you have become one central point of bringing micro optics and lasers together. What can you do for this community?
Yeah. Can you see my slide?
Yes, I can.
Yeah, because I only have one slide, so it will be very quick. I just want to present that Focuslight has positioned ourselves as a competitive LiDAR transmitter solution provider. So we basically provide all micro optics and laser transmitters for LiDARs, all kinds of LiDARs, be it industrial or be it automotive LiDAR. So we serve the customer by providing our micro optics and LiDAR transmitters. So here is one latest example. So we built this line laser module for beam steering LiDAR. The key for line laser is you got to have very thin and homogenized near infrared line beam. So this line, you see it has a 0.15 degree horizontal divergence achieved by our micro optics FEC lens. And you got to have a very long focal length, a very high quality lens to have a very thin and consistent divergence on horizontal direction. And then you also have to have a very homogenized beam on the vertical direction this way. You see it's a very top hat homogenized line beam like this one. So it's 25 degree, but it can be customized, be it 20 degree or 30 degree. So that's customizable. And so this is the line laser we built. And so this is the product LE01 module. It's a 300 watt at 905 nanometer, less than 5 nanosecond, 100 kilohertz. It's I would say this is a very good and attractive engineering sample for line beam LiDAR development. And our customers use this module to build their prototypes, their engineering and validation for a hybrid solid state line beam. This, you need to use a hybrid scheme. You got to use the rotating mirror or maps to scan the line across the FOV. The FOV will usually be 120 degree or 140 degree or 160 maximum.
Leon, let's go to your potential customer. Simon, what do you think about this line being 1D steering? Do you see potential use, or is there some room for cooperation here?
I'm definitely aware of Focuslight. So I think we have them on the list for evaluation, but I'm not in the last technical details of the technical team, but it's something that I would be very interested to learn more about after the meeting.
For me, Leon, one of the challenges that I see is 5 nanoseconds. This is, of course, a huge opportunity for cooperation. What is the target application that you go for these 5 nanoseconds?
The target application is definitely LiDAR, especially DTOF LiDAR, where you require a very short pulse for the laser power, for the laser peak power. Yeah.
Fantastic. Thank you very much, Leon, for a great presentation. Simon, many companies are already telling me that they want to get in touch. So let's make the magic happen. Let's make everyone happy for being here. It has been a very interesting meeting. I hope we make valuable use of the last 2 hours of your time. I want to summarize 2 learning points that I had come across during the meeting. The first one is that there is a lot of room for cooperation. So we had the presentation from Scantinel about the FNCW LiDAR, and they are looking for assembly partners that can actually bring the silicon nitride technology that they are working with IMEC with the active material for the no moving parts scanning. We also had a great presentation from Ommatidia LiDAR, and they're looking for testing what they already do for space, for industry automation, and for medical in other application fields. We also heard from Valeo about the new evaluation mobility kits, looking for potential partners. Sense Photonics, they are one of the stars of this show, looking for assembly of optics and micro optics, especially active alignment. We prepared too many introductions. Elmos was looking for big cells and S-pads. Jabil was looking for rapid prototyping of printed lenses with less than 10 nanometers accuracy. So companies like Multiphoton, Nanoscribe, Vanguard Photonics, this is a key opportunity. And also was looking for free-form optics measurement tools like Seal Optics, Asphericon. There is great room for cooperation. It's been a great meeting, and I love talking to all of you. So all I have to say is that from North, next to the sea, the weather is getting worse and worse every day. So it's really cold. And I'm from Almeria, the south of Spain. I need the warmth that the EPIC members keep giving me. Thank you for all the positive energies that you keep bringing to all the meetings. If you want to get in touch with any of the participants today, all you have to do is send me an email, jose.pozo@epic-azo.com, and I will be more than happy for making those introductions. We keep all these meetings in YouTube, in EPIC YouTube channel. If you go to epicphotonics.com, you see all the recordings of all the meetings. It's great material, more than 300 hours of meetings. On behalf of a great team with medical expert, integrated photonic expert, laser optics, the best innovation manager in the world, Antonio Raspa, and Carlos Lee as the person behind all this, I would like to say, stay healthy, be safe, wash your hands, and soon we'll be traveling again. From North next to the sea, it is the middle of the night already here. Take care of each other. Bye bye.